So our goal for this is to create basically what you can see here. So this is our object, and over here is where the top of our image of this object would appear if this line right here is our mirror. So, with that in mind, we have our clean GeoGebra screen. So, first thing, we go to View, and we want our grid, but we don't really need our axis. Then, we make 2 points. So, make your points anywhere, and then you need to connect them with a line. In doing this, we are creating our mirror. So, now we need to create our axis that our object will be on. So we have a point, and we can create a perpendicular line from our mirror. So this is our optical axis. Now, if we create a point above our optical axis, this is the top of our image. And we can now create a segment between 2 points that connects the top of our image to the bottom of our image. So, this line is now, actually, you can also create a perpendicular line along here, such that a point on that line will now stay along this axis. So if we move E up and down, it stays along the line, even if we try and go side to side. So we can not show D, because that's not necessary any longer. And we can create a line segment between E and C to be the line connecting the top of our image, the top of our object, to the bottom of our object. So we're not going to show our perpendicular line because we don't need it anymore. Now, we also don't need C any longer. Okay, so now that we have our object that can be any height, above or below the axis, we now want to see where the image would appear on the other side. So what we need to do is we need to create a dot at the intersection of 2 points, which is right here. Intersect 2 objects. So we're going to make a dot with the intersect of this line and this line. So that dot is now F. So now we can connect a segment between 2 points where light from E hits the mirror at point F. Using this button up here, the reflect object about line, we can also reflect object E about our optical axis so that we can see where this line hitting the mirror will reflect to. So now instead of a segment, we're going to create a ray through 2 points. So our ray goes from the mirror to E. And there you go. Using this, we can backtrace and basically determine where our image is going to appear over on this side. So by backtracing, we can go from E to point F in this direction to see, and let's make this a little clearer, object properties for that particular line. Style, we're going to make it a dotted line because it's behind the mirror. Okay, so now we want to see where another line that hits the mirror will reflect back to, and where its backtrace ray will intersect on the other side of the mirror. So let's make our mirror a little darker, shall we? Just so that we know that this is our mirror. Mirror under basic, and for style, we'll just make it a little thicker. Close. Now you can see that this is our mirror. So now we want a perpendicular line connecting E to our mirror. So this shows that light coming from reflected off of point E will hit the mirror perpendicularly and bounce backwards. So to show that, we can do our ray through 2 points. Well, actually, we need an intersect point first, where these two lines intersect at the mirror, in order to have a ray coming in and hitting the mirror and then bouncing off in this direction, and an intersect point on this side, so that we can see where those two images will interact. Now, we're not going to show our perpendicular line because that goes completely through the mirror, and we know that light rays do not go all the way through the mirror. So what we can do is we can do a ray through 2 points from G to H and make this a dotted line. Object properties, line style, dotted, to show that this is where our image is, and the two dotted lines show that the image is located behind the mirror. Now, what we can do with this is that we can now move E up and down, and you can see that this object, regardless of where you put it, the image is always the same distance away from the mirror and the same height as it is originally. Using this GeoGebra, we can also determine what the angle of incidence between E, F, and C is. And although it is a little hard to see, I think that says 38.17, as well as our angle between C, F, and E prime, which is also 38.17. So here we see that our angle of incidence, right, angle of incidence has the same value as our angle of reflection. These two have the same value. So, this is a quick and easy way to test out the law of reflection as we've learned it, using a simple simulation in GeoGebra. And you all can create it yourself, and you can see that regardless of what your angle is, the two angles are always the same. Okay? And using some other techniques, you can also match up this point so that it's not fixed at a certain spot, so that you can also move D closer and further away, which also changes the two angles, but the two angles still always equal each other. Okay? Sounds great.